Welcome to V-Guide TV. In this video, I'm explaining the chapter Electricity. What is electricity? Electricity means it plays a vital role in our daily life. Can you imagine a situation in which there is no current? There is no current, no electrical or electronic devices work. In our daily life, can you imagine we can live without bulb, fan, AC, electric iron, geyser, fridge, TV. In these all devices, we need electricity. So, what is electricity and what are the factors depends on electricity, or what are the factors depends on electric current? So in our day-to-day life, electricity or electric current plays a vital role. Plays a vital role means very important role. In these days, we can't live without electricity. So in this chapter, I want to discuss about what are the factors depends on electric current. Okay? So we will go to electric current. Before going electric current, I need to explain what is called air current. Air current is nothing but movement of air particles. Water current means it is nothing but the movement of water particles. Right? So, electric current means it is nothing but the movement of electric charged particles. Movement of electric charged particles. What are called charged particles? What are called charged particles? We know that there are two types of charges, positive charged particles and negative charged particles. In an atom, we know that positive charged particles are protons and negative charged particles are electrons. So, we are already familiar with charged particles. Okay. So, the movement of these type of charged particles is called by the name electric current. Movement of electric charged particles. So, current is a term related with a movement. Current is a term related with movement. So, air current means movement of air particles, water current means movement of water particles, and electric current is nothing but the movement of electric charged particles. Then, before going in depth, I am telling few terms in electric current. We call circuit, electric circuit. What is called a circuit? Circuit means a continuous closed path of an electric current is called an electric circuit. The continuous closed path. What's the meaning? I told you the charged particle should move. Where it should move? It should move in a closed path. The charges should move in a which path? A closed path, and it should be continuous. That path we call by a name electric circuit. So, if the charged particle should move means I need a cell, I need a bulb to understand whether there is charged particle movement is there or not, and I need a switch. So, my simple circuit starts with a bulb connected to a cell with a wire and connected with a switch. Okay, you can take a cell what we are using in the remote and all. You take a cell. With that, you connect a very small bulb like a torch bulb and a very small bulb will get it. Take a wire and connect to a cell and then to a switch and then to a bulb. You can see that if the current flows, the bulb will close. So what is that path? That continuous closed path I term as a circuit. Clear? A continuous closed path of an electric current is called by the name electric circuit. Then, what is called a switch? Switch is nothing but it's a conducting link between the cell and a bulb. We know that if we want to switch on our bulb, definitely you have to put the switch on, right? If the bulb should get glow means you have to switch on. Bulb should get off means you have to switch it off. So switch is a connecting link or a conducting link between the cell and the bulb. Okay. So switch is a link, you understand. Switch is a link. Okay. I will show an electric circuit and all. Before that, I'll just tell what is a current. I'm going to tell a definition now. I told in a simple form, it is nothing but the movement of charged particles. Now, I'm telling in the form of a definition. Electric current is nothing but the amount of charge flowing through a particular area in unit time. It is nothing but the amount of charge flowing through a particular area in unit time. Amount of charge flowing through a particular area in unit time. In unit time means I can call by another name the rate of flow of electric charges called electric current. Rate of flow of electric charges is also termed as your current. And another main thing, mostly we take the movement of electrons as the direction of current. It means that electrons move from negative terminal to positive terminal of the cell. Electrons move from negative terminal to the positive terminal of the cell. Okay? But we have taken the direction of current is opposite to the movement of electrons. That means from positive to negative. That is equal to the flow of positive charge direction. I'll repeat. I told you current is nothing but the amount of charge flowing per unit area, per unit time. We have two types of charges, positive and negative charges. So we are dealing with the electrons here. So electrons are moving from which terminal to which terminal? Electrons are negatively charged. So it moves towards which terminal? Positive terminal. Electrons move from negative terminal to positive terminal of the cell. But the conventional direction of current we are taken opposite to this. Opposite to this is it is moving from positive to negative. It means the positive charge particle always will move towards, positive charge particle will move from positive to negative. So here you have to remember what is the definition of a current. Definition of current is amount of charge flowing per unit area in unit time, or amount of charge flowing through a particular area in unit time, through a particular area in unit time. The rate of flow of charges, or electrons are moving from negative terminal to positive terminal, and the direction of current is taken as opposite to the movement of electron. That means it is equal to the movement of positive charges. I hope you got clear what is current. Current is nothing but in simple form, rate of flow of electric charges. So I like always this definition only, very simple, rate of flow of electric charges. Now next we are going to discuss about our circuit, and I am writing an equation for the current. I told you already what is a circuit. It consists of a cell. This is the symbol of a cell. You already learned, I think. As there are two cells, we can call it as a battery also. Okay. So this is a cell or a battery. And see, this is the symbol of a bulb. This is A. A, I'll discuss you. It is called an ammeter. It is the instrument used to measure current. And this is called switch. I put a dot inside. It means that switch is closed. Switch is closed means current flows. What's the meaning? If you are putting it like this means, what is the meaning? Switch is closed. Switch is closed. What is the meaning of closed? Current flows. Symbol of current only I. Current flows. So this is a simple electric circuit. Cell, bulb, ammeter and a switch. I put the switch on. So current flows from the positive terminal, because I told you just now it is taken as the direction from positive to negative. So that's what arrow mark is going away from positive and arrow mark is coming towards negative. A schematic diagram of electric circuit consists of a cell, electric bulb, ammeter and a plug key. And I told what is the meaning of this one? Switch is closed. What's the meaning of switch closed? Current flows. Then can you tell me what will be the opposite? Switch open. What is the meaning of switch open? No current flows. That simple means just do it like this only. Okay, it means that switch is open. Open means, what is the meaning? No current. No current. Now, I'll go for a mathematical expression. Let Q be the net charge. So, you got two ideas now. Charge symbol is Q. What's the symbol of charge? Q. Q be the net charge through any cross section of a conductor in a time t. Then current I. So you are getting a new letter I. I is the symbol of current. The current I, you can tell that you already told the definition in the previous page, that rate of flow of charges. Rate means divided by time. Whose rate? Charge rate. What is the symbol of charge? Q. So I equals Q by T. I equals Q by T. Current is nothing but rate of flow of charges. Clear? So two new letters I introduce now. Q and I. Q is for charge. I is for current. So current is Q by T because we defined as rate of flow of charges. Rate means divided by time. Rate of charge means charge divided by time. Clear? Good. Now, I'll go for the unit. This is also new for you. Charge unit Q is coulombs. Charge unit Q is coulombs and symbol is capital C. SI unit of time is second. SI unit of current is ampere. SI unit of current is ampere. Clear? Now, ampere means in favor of, or to remember, a French scientist, André Marie Ampere. André Marie Ampere, they put in regards of French scientist André Marie Ampere, the symbol of current or the SI unit of current is ampere and its symbol is capital letter A. Time symbol is small letter S. Right? So, I can write the same equation in form of a unit. How? 1 ampere, that means current unit. 1 ampere equals 1 coulomb by 1 second. Why I did 1? Because in unitary method, simple to understand. 1 ampere if you want, 1 coulomb by 1 second you do, you will get 1 ampere. So I can tell 1 ampere is the flow of 1 coulomb per second or per 1 second. Okay, I'm just telling here 1 ampere is the flow of 1 coulomb per 1 second. 1 coulomb per second. So shall I repeat again? I was talking about the electric circuit. Simple circuit consists of a cell, bulb, a meter and a key. And or key is also called switch. Okay, switch means key only. Okay, don't be confused. So here I marked arrow mark like this because I told you current flow from positive to negative terminal. Current flow from positive to negative terminal. Very good. Now I put two symbols here. First one is switch. Switch, I put two brackets like this and a dot in the middle means switch is closed. Switch is closed means current flows in the circuit. But you can see some circuit in which here there is no dot. It means that current switch is open. Means no current flows. Clear? Now I am getting a mathematical expression. Let Q be the charge flows in a time of t. Your current is Q by T because current is rate of flow of charges. Then I am talking about the units. The SI unit of Q is coulomb, SI unit of time is second, SI unit of current is ampere. Symbol is C, small as capital A. So 1 ampere can also be written as 1 coulomb by 1 second. So 1 ampere is the flow of 1 coulomb per second. Clear? Now, I told you I'll discuss about ammeter. Ammeter is an instrument measures electric current in the circuit. Ammeter always connects series in a circuit. Okay, in the coming videos, I'll explain more clearly about series. Now you just understand in the same path only, you just connect an ammeter. It is called a series connection. Okay, so same current flows through this ammeter also, so it is termed as a series connection. Now you just understand like that. In the coming video, I'll give a separate video for series connection. Now, so ammeter always connects series in a circuit. Very important point it is. Next, see if the current is not 1 ampere. There may be small currents also. We know the length we can express in kilometer, meter, centimeter, millimeter. Same like that, the small current is called milliampere. Smaller capital A. That means milli means divided by 1000. That means multiply with 10 power minus 3 ampere. Or you can tell 1 milliampere is 1 into 10 power minus 3 ampere. Sometimes very small current flows to a circuit. So we should write milliampere. So what is the meaning of 1 milliampere? 5 into 10 power minus 3. If they are given in the question 2 milliampere means what you should write? 2 into 10 power minus 3 ampere. But lesser than that, one more current is there. That is called microampere. What is 1 microampere? It is lesser than milli. So it is 1 into 10 power minus 6 ampere. For example, if it is 5, micro symbol is mu. What is that? Mu. This is called mu. It is a symbol. Okay. Mu ampere is 5 into 10 power minus 6 ampere. How I will write mu, you know? I will write one standing line and I'll put a U. Okay. So microampere, 1 microampere. Listen. Okay. Now I'll do a simple question. A current of 0.5 ampere is drawn by a filament of electric bulb for 10 minutes. Find the amount of electric charge through it. Simple question. They gave current, they gave time. Just now only we wrote the equation. I is equal to, what is the equation we wrote? Q by T. So what is Q? Cross multiply IT. I they gave it in the question as 0.5 ampere. But time, for confusing, they gave 10 minutes. You know that SI unit of time is seconds. So we should convert minute to second. That is 600 seconds. So Q equals IT 0.5 into 600, that is 300 coulombs. I hope you understood this. Okay. So ammeter is an instrument used to measure current. It connects series in a circuit. Then I told about milliampere 10 power minus 3, microampere 10 power minus 6 and a numerical. I equal Q by T. Therefore Q is equal to, what is equation for Q? IT. Now, I'll tell a very important point you should remember. We were talking about electrons and electrons are moving from negative to positive terminal, I told. What is the charge of an electron? You have to remember this value. The charge of electron is 1.6 into 10 power minus 19 coulomb. Very important value. 1.6 into 10 power minus 19 coulomb is the charge of an electron. Okay. Next, I want to tell a very funny thing. How many electrons constitute 1 coulomb? We know 1 kg of apple may be 4 or 5 pieces. 1 kg of grapes means it has how many small pieces? It may be some 100 pieces. What is called a 1 coulomb of charge? So I don't know. 1 coulomb means I don't know how many electrons constitute 1 coulomb. So I'm just using a simple maths. 1 coulomb means I don't know. So I put NE. So and so electrons constitute 1 coulomb, right? So I'm writing 1 coulomb is equal to N into E. So N equals 1 coulomb by E. That is 1 coulomb by, what is our E? 1.6 into 10 power minus 19 coulomb. Coulomb cancel. Now I'm doing an easy calculation. 10 power 19 goes up. I can write 10 into 10 power 18. I just split it. No problem, no? 10 into 10 power 18. It's for my convenience I did like that. So 10 by 1.6 is 6.25 into 10 power 18. So just imagine 1 coulomb means 6.25 into 10 power 18 electrons constitute 1 coulomb. Not like one electron constitute 1 coulomb. This many electrons we need to get 1 coulomb of charge. Clear? 1 coulomb contains 6.25 into 10 power 18 electrons. What is the charge of an electron? 1.6 into 10 power minus 19 coulombs. Clear? Okay. Next, I am going for an important topic of current, that is called electric potential or potential difference. Electric potential or potential difference. Before that, I am telling a small experiment. Take two beakers. One beaker contains water up to this level and another beaker contains water up to this level. I am just connecting it with a pipe. Okay. So, we know that there is no possibility of the current flow from low height to higher height. The current or the water flow from high potential to low. You can see that the water in this beaker level will come down and this will go up. Okay, so the meaning is the water can move from the high pressure to a low pressure. As here water is more, here pressure is more. So it moves from high pressure to low pressure. High pressure to low pressure. So due to the pressure difference of two beakers, water flows from high potential to or high pressure to low pressure. Similarly, if you take air also, air moves from high pressure to low pressure. In the similar form, the current also flows from a high pressure or a high potential region to a low potential region. Who is giving the difference in a current circuit or an electric circuit? Our cells. Have you seen our cells? So cells will give this potential. Inside the cell we know chemicals are there. So chemical energy is there. So I can tell that current flows only when there is a difference in potential, because here we have seen water flow from high region to low region. So same like that, current flow from high potential region to a low potential region. And this difference is produced by cells or battery in a circuit. When the cell is connected, the potential difference sets the charges in motion in the conductor and produces electric current. Okay, so how an electric current is produced? When we connect a cell, inside the cell chemical reactions takes place and this cell produces a potential difference, and this potential difference helps the charges to move from one end to another point. So who is giving an energy for the cell? Chemical reaction takes place inside the cell, generates potential difference. So I need to tell why we are connecting a cell or a battery in a circuit, because we need energy. We need an energy to push our electrons. So that is called by the name potential difference. Potential difference is nothing but the difference in potential. So whenever there is a difference in potential, then only charge can move. In all the places, same potential means charges cannot flow, because we have seen this example. If the pressure is same, there is no movement. The pressure is different, then only movement is there. So same like that, current should go means, or current should flow means there should be a difference in potential. Clear? Now, electric potential difference between 2 points in an electric circuit carrying some current as defined as work done to move a unit charge from one point to another. In the previous slip I show you, I already shown you that charge move from one point to another point, right? So what is the work required to that? That work we termed as potential. Okay, simply the charge won't move, we have to apply the work. So potential difference, PD means potential difference, simple is V, between 2 points is work done by charge. For what work done? Which work done? Work done to move the charge from one point to another. That is called by the name electric potential difference. Clear? If it is only electric potential, it is a work required to move a charge from infinity to a point. Here it is a potential difference, so it is moving from one point to other point, one point to other point. So that is called potential difference. Equation is W by Q, V equal W by Q. And its SI unit is called volt. SI unit is called volt. The SI unit of potential difference is volt. SI unit of work done is joule. And the SI unit of Q is coulombs. So I can write 1 volt equals 1 joule by 1 coulomb. 1 volt is equal to 1 joule by 1 coulomb. Or you can write 1 volt is 1 joule per coulomb. Right? So I can tell that electric potential difference is nothing but the work required to move the charge from one point to another point. Same like the previous one, potential difference also you can measure with an instrument called voltmeter. The instrument called voltmeter. Okay, its symbol is V. It is connected parallel across the circuit. Parallel means across. Parallel means across the circuit, right? So for example, if this is a bulb, assume this is a bulb, parallel means across we have to connect, means like this. Across the bulb, I want to find the potential difference of the bulb, means I should connect across the bulb. This is called a parallel connection. In more detail, we will do it in the next videos. So remember, voltmeter symbol is V inside a circle. So voltmeter is connected parallel. Parallel means across. Across. Where we need to find? I need to find across the bulb here. So across the bulb. So potential difference is the instrument used to measure potential difference, and it is connected parallel across the points in which potential difference is measured. I need to do a simple question. How much work is required to move the charge of 2 coulomb across 2 points having a potential difference of 12 volt? So they gave here all the points. They gave charge, they gave potential. So Q is 2 coulomb, V is 12 volt. V equals W by Q, W equals VQ, cross multiplication. 12 into 2 is 24 joules. Very simple question only I did, nothing simple substitution. So in short, in this video, we were discussing about potential. Potential is work by charge, and the unit, I did not tell, I think, the unit, SI unit is volt, and it is in favor of an Italian scientist called Alessandro Volta. Volt is in favor of an Italian scientist, Alessandro Volta. Right? Then we did about what is the need of a potential difference. If you know this diagram, it is easy to understand because we know water flow from high potential to low potential. And the main thing you should remember is this one, charge of electron 1.6 into 10 power minus 19 coulombs, and 1 coulomb contains 6.25 into 10 power 18 electrons. An ammeter is a device used to measure current. It is connected series in a circuit. 1 milliampere, symbol you see small m A, 1 into 10 power minus 3 ampere. 1 microampere, 1 into 10 power minus 6 ampere. Okay. Then I shown a circuit. In the circuit, switch thing I told, switch or key. Dot means switch dot, switch is closed, current flows. If no dot, it means switch is open, no. Okay, switch is closed means current flows. Switch is open means no current. Clear? 1 ampere I can write as 1 coulomb by 1 second. Then the main thing, what's the direction of current? The direction of current is taken as same like the direction of positive charges, that from positive to negative, or opposite to the movement of electrons. Opposite to the movement of electrons. In short, I can tell that electric current is nothing but rate of flow of charges. I hope you like this video. If you like this video, subscribe VGuide TV and watch more videos. Thank you.